Alrighty, everybody, so we are going to talk about our last piece with parent functions. And within each parent function, remember that's like the most basic form of a function, but sometimes we want to look at other forms. So that's where we have our a value, our h value, and our k value. Remember, those are variables that fit within our equations. So, for example, okay, you don't need to write this, but just to give you some context, remember, our parent function for, say, a quadratic is y is equal to x squared. That's going to give us a nice graph that's going to go through 0, 0, and increase. But if I want my quadratic to look different, I want it moved over, I want it skinnier or narrow or upside down, all of those things happen through changing your a value, your h value, and your k value, which is how we get our transformed versions that look something like this. And all of our transformed versions have some form of a, some form of h, and some form of k somewhere in the equation, okay? So I'm going to erase this so it's not in our way. Let's get ourselves a bigger eraser here. Okay, so the first value that we're going to talk about is our a value. And our a value is always multiplied by the x term. Now that's not just the variable x, but whatever pieces are with x, okay? And we are multiplying. Now sometimes you might not know it's multiplying because it's next to a grouping, like a parentheses or a square root sign or absolute value bars. Those all group things together, okay? So our a value, some examples of where we might find those are, let's think about our quadratics for a second, like we just wrote out. There is my transformed version of a quadratic. My a value is right next to my whole x term, which is this whole thing that includes x. H is being multiplied because it's touching that parenthesis. Another example, if I use numbers, is if I had, that's a letter. K is a letter. -3, -3 plus 2x minus 5 squared. Now here my a value is a 2. It is not always the first thing. It's whatever is being multiplied by my x term. So this 2 here, not the exponent 2. Remember, this exponent 2 is just part of the equation as saying it's squared. Okay, so we want to make sure we don't pull that in, but our h is what's being multiplied out in front, or a value. Now the a value I think is the most powerful of all of our values because it has multiple roles. So when we have a positive a value, our graph opens up or faces up. So that means that absolute values are going to point up. Quadratics are going to point up. Our square root is going to move that to the right. Our cubic, oh gosh, I lost my light there, is going to go from lowest to highest, and our linear is going to go from lowest to highest. So all of those are a positive a. Now if I have a negative a, my graph is going to open down or do the opposite of all those things. So instead of pointing up, we point down. Instead of opening up, we open down. Instead of arching up, we arch down. From going lowest to highest, now we're going highest to lowest, highest to lowest. Okay? So our a has been switched, and so it flips upside down. Now a can also make a difference in the shape. When our a is between -1 and 1. So on a number line, and 1. So on a number line, 0 is here, I got 1 over here, I got -1 over here. We're talking about when we are in between, okay? In those small decimal ranges. when we are in between there, our graph gets wider. All right? And the opposite thing happens when A is smaller than -1 or bigger than 1, it gets narrower. Okay, so our graph gets wider when we have a little number, skinnier when it's a big number. Okay. Now finally, if we talk about what does our graph actually look like when these changes happen to A? Here I have a graph of a square root. Okay, so my parent function is a square root. I'm going to write that on here. My parent function is what is in orange here. It is a square root. And I write that down as y is equal to the square root of x. Okay, that is this orange trajectory here. You'll notice 2 key points, 0, 0, and 4, 2. Okay, I could keep going. 9, 3 is another one. And 16, 4 is another one. Okay. Now the only thing I changed between the orange and the blue is the A value. So I know I'm going to have y is equal to something, the square root of x. Now if I look, okay, so I have an x value of 4 here. And I want to know what happened between these two to get an output of 2 and an output of -1. Well, let's think through this. So if my x value equals 4, in my parent function, oops, y is equal to the square root of 4, which equals to 2. But I want to know y is equal to something times that equals, right, times the square root of 4. And we know in our answer we get -1, so we have some unknown, times 2. Now what do I multiply times 2 to get a -1? Well, we know because our graph flipped upside down that we are going to need a negative value for our A value. It's not going to work super well having my negative sign there. A negative, okay? And I know that 1 is half of 2. So my answer is 1/2. Okay, so my A value is equal to -0.5. So I'm going to put, oops, why is this not doing what I wanted to do? -0, oh my, I've never seen this. Sorry guys. 0.5. Okay, so here is my new function to describe this blue line here, all right? So my transformation was that my A value became negative. All right, now we're going to look at our H value. Our H value is always with x, but more specifically, oops. Oh goodness, I'm all over the place today. I'm sorry, people. Okay, our H value is always subtracted from x. All right, so we see it inside the parentheses or the grouping. Some examples I have for you are with a quadratic. Here is my H value, it's inside, okay? If I give you a real number example, y is equal to 3 times, let's do x plus 4 to the 3rd power minus 2. Here, even though it's addition, we know that adding a positive is the same as subtracting a negative. So this is like saying minus a -4, where my H is equal to -4. Okay, so I can have negative values too, which would make my equation positive. Okay. The shift that the H makes is also pretty straightforward. When I have a positive H value, it moves to the right. And when I have a negative h value, we move to the left. Mr. Lynch says hi, everybody. Okay, so my h value shifts to the left and to the right, right? So it's a movement of our graph. If I look at my example now, the example we were looking at before, this is the same exact graph, except for this time, okay, so I have changed my value so that now my orange graph is the graph we created. So our orange graph is our, let's make sure I'm writing this, our y is equal to negative 0.5 square root of x. Okay, that describes our orange graph. Okay, now our blue graph, the only change that happens between our orange graph and our blue graph is that we moved over 4. Okay, if I look at these two, oh, not that point. This point here in orange is at 4, negative 1. And then over on the blue graph, it's at 0, negative 1. So the only thing that happened was our x value moved over by 4 to the left. So my equation, it keeps the same shape, negative 0.5 square root, but now we are going to move over to the left, which means subtracting a negative 4, also known as adding 4. Okay, so here is my equation for this new graph with that change. All right. The last term that we have is our k value, and our k value is always by itself, adding or subtracting. So some examples of what I have are let's go back to our quadratic, x minus h squared plus k. See how my k is all by itself and it's being added. If I were to use actual numbers, I might get a little crazy here. Well, let's do an absolute value. Here it would be our minus 3 because that's what's by itself. This 2 is being multiplied by our x term. The 18 is inside of our grouping or our absolute value. So our h is equal to k is equal to negative 3. Now the shift that it makes, when we have a positive k value, we move up. When we have a negative k value, we move down. Okay? Pretty straightforward. Now one thing to note, and you might want to note this as like an additional note somewhere, is that the h and the k together are the vertex, endpoint, or middle of your graph. Okay? And we're going to see that in a second of the graph. So that part is going to shift to h comma k, and then the a is going to change the shape. Okay? H and k tell us where. A tells us what it looks like. Finally, when we look at our graph here, we've got the same graph we've been looking at, and I have a bunch of key points on here. So I have my graph for one final use. Remember, this is our new graph that we drew at the end of the last transformation. So we're at negative 0.5 square root of x plus 4. And the only change, and we can see it in all of our points, between the endpoint, between all these points, is that we shift down by 2. Okay? So my equation would be y is equal to negative 0.5 x plus 4 minus 2, because remember that k tells us up and down. And the last thing I want you to notice is how if I look at my endpoint here, that is exactly what my h value and my k value are. So my h and k will tell me how far to move from my parent function. Remember, my parent function was way up here looking like something like this. Okay, and it says we got to move over 4, down 2. The a tells us we're going to flip upside down and we're going to get skinny. Okay, we're going to be at half of whatever value we were at before. Okay, between one point and another. All right, so those are our key pieces of a function transformation.